We present SpaCeFormer, fast, proposal-free, open vocabulary 3D instance segmentation. Work from NVIDIA and POSTEC at ICML 2026. It predicts 3D instance masks, each with a clip feature, so instances can be labeled from any open vocabulary in about 1/10 of a second. Open vocabulary 3D instance segmentation recognizes arbitrary object categories. Key for robotics and AR, VR with 3D text data scarce, prior work splits 2 ways. Multi-stage pipelines stitch 2D outputs into 3D, but pay with compounding errors and hundreds of seconds per scene. The scalable alternative, and the route we take, is end-to-end training on pseudolabels. The catch isn't the route, it's the data. Prior pseudolabels come from single views, giving fragmented masks and inconsistent captions. We keep the route and fix the data. SpaCeFormer is proposal-free, uses only 3D input, and needs no ground truth 3D masks. On this latency versus accuracy plot, it sits alone in the top left. State-of-the-art accuracy at interactive speed. Everything else is either far slower or leans on ground truth-trained proposals or multi-view 2D streams. 4 contributions. 1. SpaCeFormer 3M, the largest open vocabulary 3D instance dataset. 2. SpaceCurve attention. 3. A rope proposal-free decoder. 4. State-of-the-art results with strong zero-shot transfer. The dataset is built with a training-free pipeline. We sample non-redundant views, aggregate 2D masks into complete 3D instances with multi-view clustering, SAM2 plus mask clustering, then caption each instance from multiple views with a VLM the result. 3 million captions over 600,000 masks across 7,000 scenes, 21 times higher mask recall than single-view pipelines, 54 versus 2.5%. Complete masks are exactly what a proposal-free decoder needs. Most 3D transformers serialize points with a space-filling curve, then attend along that 1D order. On a full grid, the Morton code takes long jumps between quadrants, scattering neighbors apart. The Hilbert curve never jumps, every step moves to an adjacent cell, so points that are close in the sequence stay close in space. On a dense grid, Hilbert gives far better locality. But real point clouds are sparse, and that breaks the curves. We group every 6 consecutive tokens along the curve into one attention window. With Morton order, the windows are spatially spread out, the widest spans almost 15 cells. Hilbert looks visually tighter, but because 6 consecutive sparse points can still trace a long, thin path, its worst-case spread stays about the same, around 14 cells. On sparse points, both curves make large jumps that destroy locality. Only fixed non-overlapping spatial windows avoid those jumps, bounding the spread to under 8 cells. One trade-off: because the cloud is sparse, each spatial window holds a different number of voxels, unlike Morton's fixed-length segments, which can make the window detention less efficient. Spatial windows preserve locality, but they are content-agnostic and cannot mix signals across the scene. So SpaCeFormer uses both, because they are complementary: non-overlapping spatial windows for locality and serialized Morton curve attention for mixing signals. We arrange this in a UNet backbone, spatial window attention at the shallow, high-resolution levels for local detail, and Morton curve attention at the deeper levels for global signal mixing. The decoder predicts masks directly from 200 learned queries, no region proposals, deter style. It refines the queries over 3 iterations of cross-attention, self-attention, and feed-forward. We apply 3D rotary position embeddings to the keys only. Because the queries skip rope, the rotated keys encode absolute coordinates, which is critical. Rope gives 7.6 MAP versus under 6 for the alternatives. The heads output a mask, a foreground score, and a clip feature. The label is the nearest text embedding by cosine similarity. The results: on replica, fully zero-shot, 24.1 MAP, 119 times faster than Open YOLO 3D on ScanNet++, 22.9 MAP, the best of any reported method, including 2D plus 3D pipelines, and over 2,000 times faster than Open Track 3D on ScanNet 200, 11.1 MAP in 1/10 of a second, 2.8 times the prior best proposal-free method. And the qualitative masks are tight, including categories well outside the training taxonomy. To summarize, a large training-free dataset, SpaceCurve attention for coherent features, and a rope proposal-free decoder, together, fast, open vocabulary 3D segmentation that is state-of-the-art at interactive speed. Thank you.